So for this problem, they're asking you to integrate 5e to the 2x plus 1 over x. So what you want to do with this problem is you want to use properties of integrals and separate it with the addition and also pull out the 5. So I'm going to rewrite it like this. So it's going to be 5, the integral of e to the 2x, and then dx, plus, and then the integral of 1 over x dx. And then for right here, you don't have to, but a good idea is to use u substitution here. So we're going to let u be 2x, and then du would be 2 dx. So we're going to need a 2 here, and to compensate for that, we're going to have to multiply by 1/2, which gives you 5 halves out here on the outside. So this would be 5 halves, the integral of e to the 2x times 2 dx, and then plus the integral of 1 over x dx. And so this becomes 5 halves the integral of e to the u du plus the integral of 1 over x dx. And the integral of e to the u is e to the u. So this would be 5 halves e to the u, and then plus the integral of 1 over x is the natural log of the absolute value of x, and then plus a constant c. And then we got to remember to go back and replace the u with what u is equal to in this case, because we're asking really for antiderivatives here. And so we want to replace that back with 2x. So the final answer would be 5 halves e to the 2x plus the natural log of the absolute value of x plus c. And so the correct answer for this one is answer B. So for this problem, we want to find the derivative at 4 for the function the square root of x plus 3 over the square root of x. So really what we want to do is we want to rewrite this. So square root of x is really x to the 1/2. And 3 over the square root of x would be plus 3x to the negative 1/2. And then we're just going to apply the power rule to this. So f prime of x would equal 1/2 x to the negative 1/2 plus 3 times negative 1/2 x to the negative 3/2 power. And so that makes f prime of x equal to 1 over 2 square root of x minus, because I'm multiplying, 3 over 2 the square root of x, raise that to the 3rd power. So then f prime of 4 would be 1 over 2 square roots of 4 minus 3 over 2 the square root of 4 cubed. And so this would be 1 over 2 times 2, so that'd be 1/4 minus, and that'd be 2, and 2 cubed is 8, so this would be 3 over 16. And common denominator here, we would need to multiply by 4 over 4, so that makes 4 over 16 minus 3 over 16, which gives you a value for f prime of 4 of 1/16, and so the correct answer is A. So for question number 3, we want to integrate x squared times the quantity x cubed plus 5 raised to the 6th and dx. And really for this problem, what you have to recognize is that if you take the derivative of this inside, it's going to give you 3x squared. And so we have an x squared, we're multiplying by x squared out here. So this is a perfect case for integration by substitution. So we're going to let u equal x cubed plus 5, and then du would equal 3x squared. So I need a 3 with this, so I'm going to multiply by 1/3 on the outside and 3 on the inside, and then x cubed plus 5 raised to the 6th dx. And so this becomes 1/3 the integral, and this, the 3x squared along with dx, becomes my du. So really this is just u to the 6th du, and then we can just apply the power rule for integrals, and this would be 1/3 u to the 7th over 7, and then plus some constant c. So that would make 1 over 21, And then u, our u is x cubed plus 5. So this would be x cubed plus 5 raised to the 7th plus c. And so the only correct answer here is E. Let's go to number 4. So for problem number 4, we have the values of a continuous function f for selected values of x that are given in the table above. What is the value of the left Riemann sum approximation from 0 to 50 of f of x dx? And then they're telling you what intervals to use. So 0 to 25, and then 25 to 30, and then 30 to 50, okay? So these are going to be our widths of our rectangles. And so what we need is we're doing a left Riemann. So that's going to be the left side of the rectangle. So from 0 to 25, the left side would be 0, 25 to 30, left side is at 25, and so on, okay? So we would have the integral from 0 to 50 f of x dx. And so the left side would be 4, and then times the width, which would be 25. And then plus, and then between 25 and 30, the left side would be at 25. So it's going to be 6 times 5. And then plus, and then the last one is going to be, the left side would be at 30. So it's going to be a height of 8. And then times the width, which would be 20. Because we're going from 30 to 50, okay? So then this would be 100 plus 30. And then plus, and then 8 times 20, well, 8 times 2 is 16, so this would be 160. And so these two added together would give you 260. And so this gives you 290. And so the correct answer is A. So problem number 5, they're saying let f be the function defined above, where c is a constant. So c right here is a constant. For what value of c, if any, is f continuous at x equals 2? So one thing is the limit has to exist at 2, the function has to exist, and for the limit to exist, the one-sided limits have to be equal to each other. So for this to exist, we have to find the limit as x approaches this 2 from the left. Now from the left, we're going to pick this function. So it's going to be x squared sine of pi x, and then that would have to be the same as the limit as x approaches 2 from the right. And from the right, we're going to use this function. So x squared plus cx minus 18. Now, really to do this, all we have to do is substitute values in. So if we put 2 in here for x, that would give me 2 squared, and then sine of, and then 2 times pi, which would be 2 pi, is equal to, and this we would plug in the 2. So this would be 2 squared plus c times 2 minus 18. Okay, so 2 squared would be 4, and sine of 2 pi would be 0. And then this would equal 4 plus 2c minus 18. And so we can combine these, and this left-hand side is 0. This right-hand side becomes minus 14 plus 2c. And move the 14 over, we get 14 is equal to 2c. And then 14 divided by 2 is 7. And so c would have to equal 7. And so the correct answer is B for number 5. Okay? So for number 6, which of the following is an antiderivative of 3 secant squared x plus 2? So to find an antiderivative, that's the same as an integral. So 3 secant squared x plus 2, and then dx. And so really we've got to break this up. So, and I'm going to break this up with the sum and also factor out the 3. So it's going to be 3 integral secant squared x dx, and then plus 2 times the integral of dx. So this would equal 3, and then the derivative of tan is secant squared. So the antiderivative of secant squared would be tan of x, and plus, and the antiderivative dx is just x. So this would be plus 2x. And then plus some constant c, but you notice that none of the answers have that. So really we're just looking for 3 tan x plus 2x, right? And so that correct answer would be B for number 6. So in number 7, they're giving you f of x is equal to x squared minus 4, and g is a differentiable function of x. What is the derivative of f of g of x? So this is a composition of functions, so we're going to have to apply the chain rule. So d dx of g of, not g, hold on. Let me fix that, f of g. So f of g of x is equal to, so the derivative of the outside function, so that'd be f prime of g of x, and then times g prime of x. So the derivative of the outside function, keeping the inside function inside, and then multiply by the derivative of the inside function. Okay? Now, what is f prime? So we know f of x is equal to x squared minus 4. So f prime of x would be equal to 2x. And then what we're going to do, okay, so that means over here, this is telling us to put g of x into f prime. So that means this would be equal to 2 times g of x times g prime of x, or 2g of x times g prime of x, like this. And so the only answer that's like that is D. And so that's the correct answer for number 7. So for this problem, we're shown a slope field for the differential equation here. And if y equals g of x is the solution to the differential equation with the initial condition g of -2 is equal to -1, then what is the limit as x approaches infinity g of x? What is it, right? So what I would do is take this point right here, -2, -1. So -2 is probably right about in here, and go down to -1, right? So we're talking about right in here. And so this is a particular solution of it, right? And so if we draw this, it kind of looks like the curve is going this way, right? And it looks like if we follow these lines, it's approaching the x-axis here. So that would mean the limit as x approaches infinity of g of x would be equal to 0. It's getting closer and closer to being 0. So the correct answer here is C. So for this next problem, if f double prime of x is equal to x times the quantity x plus 2 squared, then the graph of f is concave up 4. And so really this is the concavity test. So the very first thing we want to do is, okay, when is the second derivative equal to 0? So we're going to set x times x plus 2 squared equal to 0. And so this is going to happen when x equals 0 and also when x equals -2. So then we're going to set up a sign chart. So we're going to go from -infinity for the interval up to the first of these, which is -2, and then -2 to 0, and then 0 to positive infinity. In here, I would use x equals -3. Here, x equals -1 for our test points. Here, x equals 1. And then when we put this into the second derivative, it's going to tell us the concavity. Okay, so when we put -3 in here, the first factor, which is x right here, is going to give me a negative value because it's -3, right? And so I'm not worried about the number value. I'm worried about the sign. So when we put the -3 in here, we're going to get a negative value, but I'm going to square it. So that's going to make this a positive. So I have a negative times a positive, which is going to give me a negative. And that would tell me it's concave down. So on that interval, the graph of f would be concave down. We're looking for concave up, so that's not it. So x equals -1, so we put that right here. That'd be -1. -1 plus 2. Okay, so -1 plus 2, that'd be a positive, and I'm going to square that, and a positive squared is still positive, times a negative. So this is going to be an overall negative, which is, again, concave down, because the second derivative is negative in that interval. And then from 0 to infinity, x equals 1. So the first one would be positive, right? Because it'd be +1 right here. And then 1 plus 2, well, that'd be 3, which is positive. And we're going to square it, right? So that's going to give me positive. So that tells me the second derivative on that interval is positive, which tells me the graph of f is concave up. So concave up. So from 0 to infinity. Now notice it's not an interval notation, right? So another way of saying interval of 0 to infinity would be, we would be saying x is greater than 0. So x is greater than 0 is right here for B. Correct answer is B. So for number 10, if y equals sine x cosine x, then at x equals pi over 3, what is the derivative? So this is a product, so we're going to have to apply the product rule to this. So dy over dx is equal to the derivative of sine x, which would be cosine of x, times the second function, which is cosine x, plus the first function, which is sine of x, times the derivative of cosine of x, which is negative sine of x. So our derivative winds up being equal to cosine squared x minus sine squared x. So putting pi over 3 in here, okay, so dy over dx at x equals pi over 3, that would give us cosine of pi over 3. And then what we need to do is square that, right? Okay, and then minus, and then sine of pi over 3 squared. And so we're going to draw our triangle for pi over 3. So pi over 3 is in the first quadrant. My rotation is pi over 3. The opposite leg right here would be the square root of 3. This would be 1, and this would be 2. So cosine, it would be 1 over 2. And we would need to square that, minus, and then sine of pi over 3 would be square root of 3 over 2. And we would need to square that. So this becomes 1/4 minus 3/4, or negative 2/4, which is really negative 1/2. So the derivative of pi over 3 is negative 1/2, and the correct answer is A. So I'm looking at this problem, and limit as x approaches negative 3, and we should be thinking direct substitution, but I'm seeing, possibly, these two things I can factor. So I'm thinking we're not going to be able to do direct substitution, so I'm going to go right to factoring. So this is equal to the limit as x approaches negative 3. X squared minus 9, that's a difference of squares, so that factors into x minus 3 times x plus 3. And then x squared minus 2x minus 15, that one's going to factor into x minus 5 and x plus 3. So recall that there's going to be a removable discontinuity here, right? So when x equals negative 3, that's going to make the numerator and denominator 0. So if I had tried to do direct substitution in here, I would have gotten 0 over 0. Now, another way to do this is we could have used L'Hopital's rule on this. Okay, I think it's quicker and easier to factor, though, than to use L'Hopital's rule. Okay, so for this, the x plus 3's cancel, so you're left with the limit as x approaches negative 3 of x minus 3 over x minus 5. And then now we can do the direct substitution. The numerator becomes negative 6, and the denominator becomes negative 8. And so that makes positive 3/4. So correct answer for number 11 is C. So for this problem, number 12, we're asking what is the average rate of change of y equals cosine 2x on the interval 0 to pi over 2. Now, we got to remember the difference between there's average rate of change and there's average value of the function. So average rate of change is the slope of this function between these 2 points, these 2 endpoints. So this becomes cosine of 2 times pi over 2, because that's the right endpoint, minus cosine of 2 times 0, because that's the left endpoint, over pi over 2 minus 0. So this becomes cosine of pi minus cosine of 0 over pi over 2 minus 0, which would just be pi over 2. And then cosine of pi. Well, cosine of pi, recall that it's right here, right? So that angle is pi. And so cosine of pi would be negative 1. minus, and cosine of 0, well, cosine of 0 right here, cosine of 0 is 1, so we're going to subtract 1 over pi over 2. So -1 minus 1 is -2 over pi over 2. And then what we're going to do, because this is a complex fraction, is we're going to multiply by 2 over 2. And this gives you a numerator of -4 and denominator of pi. So our average rate of change between 0 and pi over 2 for this function cosine of 2x is -4 over, and I put 2, and I meant to write pi. Probably caught that. So this should be -4 over pi. And so the correct answer is A. So for number 13, if y cubed plus y is equal to x squared, then dy over dx, what is the derivative of this? So we have to use implicit differentiation on this. So we want to take the derivative with respect to x of both sides. For the sake of time during the AP exam, I wouldn't bother to write this line that I'm writing right now. This is just if it was a regular test. Okay, so the derivative of this would be, we'd have to apply the power rule along with the chain rule. So this would be 3y squared, but the derivative of the inside, which is y, with respect to x, would be dy over dx. And then plus the derivative of y with respect to x would be just plain old dy over dx is equal to, and the derivative of x squared with respect to x would be 2x. The derivative of x with respect to x, though, was just 1, so that's why we're not going to write dx over dx right here. It's just 1. So right here on this side, what we can do is we can factor out a dy over dx. And what we're left with is 3y squared plus 1 is equal to 2x. And then all I need to do is divide by 3y squared plus 1. So dy over dx is equal to 2x over 3y squared plus 1. And if you look, answer E is equivalent to this, right? Because it doesn't matter. The order of addition doesn't matter. Subtraction, it would matter, but not for addition. So this is an equivalent answer right here, is E. So the graph of y equals f of x on the closed interval 0 to 4 is shown above. Which of the following could be the graph of y equals f prime of x? So if you look from here to here, from 0 to, it looks like about 2, right in the middle between 0 and 4. All these slopes look like they're negative, but this one's is 0 right here. So that looks like a horizontal tangent right there. So that means the graph would be 0 there also, okay? And all of these are positive. So this is negative. All of these are negative slopes, and all of these are positive. So we're looking for, right in between 0 and 4, the derivative going from below the x-axis, because it's negative, to being above. So that's not happening here. It's definitely not happening here. Here, this could be it. This could be it. Okay, this couldn't be it. So because it's only changing from negative to positive. Okay, so could it be this one or could it be this one, right? Now, if you look right here at 4, it looks like we kind of are starting to look like a horizontal asymptote right there. So our slope is going to be really, really close to being 0. And then also right here. So what is that? How does that show up on the derivative graph? Well, right here, this would be an x-intercept because that'd be, the slope would be 0. And here the slope would be 0. And here the slope would be 0. So right here, the slope isn't 0, but right here, it's kind of looking like it's really close to it, right? And then same thing here. So really the only answer that could possibly be this one is this one right here. And so the correct answer is D for number 14.